Here's an example of a sort of polar calculus question that loves to crop up on the Calc BC exam. This is an actual question from either a practice exam or a prior exam. I don't remember off the top of my head which. But this is, again, this is a classic sort of thing you're going to see on any Calc BC exam, an old exam, and almost certainly we'll see on future exams. So this is a with calculator. This is on the calculator part, so we're going to use our graph calculator to do some of the hard work, but we're going to need to have some knowledge of these polar coordinates, polar calculus, to at least get the integrals and things set up to plug into our calculator. The graphs of the polar curves of r equals 3 and r equals 4 minus 2 sine theta are shown in this figure. And they intersect when theta is equal to pi over 6, so right here. And when theta is equal to 5 pi over 6, right here. Part A says let S be the shaded region that's inside of both graphs. Find this area. When I look at this, I see this as finding the area. Well, this is obviously between two different curves. I'm going to find the area inside the innermost curve in this thing, and it looks like there's two distinct regions. At least this is how I think of it. I think of this region that's bounded by the circle r equals 3. I think of this as like region 1, and then I think of the rest of this as the bounded by this kind of fancier curve 4 minus 2 sine theta. I think of this as like region 2. So if I can, I think that the total area is just each of these two areas added together. So I think for part A, I'm going to divide this into two separate regions. Find the area of each, then add. So I think the easier of the two is 1, because this is just a circle with a radius 3. This is a circle of radius 3. With this sector between pi over 6 and 5 pi over 6 removed. What is that? Well, that's, if you remember, the sector area formula is 1/2 r squared times theta in radians. The radius of the circle is 3. So in our case here, we know that r is equal to 3. And what is theta? What is the amount of rotation you go from here? Well, I think the theta is going to be the full circle minus the amount you rotate from 5 pi over 6 to 1 pi over 6, which is 4 pi over 6, which is 2 pi over 3. This is like, how about 6 pi over 3 minus 2 pi over 3, which is 4 pi over 3. So that's 1/2 times 4 pi over 3 times 9. How about 2/3 times pi times 9? 2/3 of 9 is 6. So I think the area of sector 1 is 6 pi. The area of sector 2, well, that's not as easy because it's not just a circle. You can't really use geometry to do that, but we can use calculus because we know how to find the area. We could find the area bounded by this curve. In sector 2, it's bounded by this curve 4 minus 2 sine theta. And it's between pi over 6 and 5 pi over 6. So the area is this integral from pi over 6 to 5 pi over 6. And the formula, as we just saw, is 1/2 times the function, the radius as a function of theta squared, which is in our case 4 minus 2 sine theta squared d theta. This is on the calculator part, so I don't think it's definitely not worth your time to try to expand this binomial and do this by hand. Let's use the numerical integration on our graph calculator to do this. Use our graphic display calculator, numerical integration. And on my graph calculator, I'm going to add a new calculator page. Excuse me. I'm going to use menu, calculus, numerical integral. Just for ease of typing, I'm gonna type x's instead of thetas, but it doesn't really matter. I'm gonna do pi over 6, pi over 6 to 5 pi over 6. And my rule is 1/2 times 4 minus 2 sine theta, 4 minus 2 sine of theta. I'll call it x dx, which yields about 2.45674. So add these two things together. 6 pi plus previous answer. Turns out that I need to go back because I forgot the square. Luckily, calculator will let you do that. I'm just going to go up, highlight, hit enter. I'm going to go back in and add in. Hopefully, you were screaming through your video screen that I should be squaring that radius. That's a lot better. How about 5.859 blah blah blah? And now I'll take 6 pi plus that answer, and voila. So total area is this is for the Calc BC exam. So if we'll go to the third decimal place, how about 24.709 units. Part B says a particle moves along the polar curve 4 minus 2 sine theta, so that this kind of wavy one, the bigger one, so that at time t seconds, theta is equal to t squared. So find the time in the interval between 1 and 2 for which the x-coordinate of the particle is at position -1. So note that in polar coordinates, x is equal to r of theta times cosine theta. We know what this function is. This function is the rule for the function, which is 4 minus 2 sines of theta times cosine of theta. And theta is equal to t squared. So I'm going to plug in, I'll just substitute in t squared for theta. So this is 4 minus 2 sines of t squared times cosine of t squared. And I want the x-coordinate to be -1, so I set this equal to -1. So again, you could try to solve this equation somehow. I'm sure it's possible, or maybe it's possible. It might not be, but it is possible to do to get a numerical estimate using a graphing calculator. So I'm going to use this to find the solution of t when these are equal, and that solution has to be between 1 and 2. So again, you could use maybe the numerical solver. I'm going to solve this by graphing and look at the interval between 1 and 2. So I'm going to add a graphs page. I'm going to graph the left-hand side. 4 minus 2 sines of, I'll use x instead of t, t squared times cosine of x squared. And gives me this crazy thing. That's cool. I want a horizontal line of -1. And I need the interval between 1 and 2. So I need to zoom in here. So maybe I'll use my menu. I'll change the window. And I know that I don't care about x between -10 and 10. How about between 0 and, say, 3? It intersects 3 times in between 0 and 3, and I'm pretty sure only one of these will be between 1 and 2. So maybe I'll just quickly check. I think it's going to be the first one. Between 1 and 2 is this value of 2 right here. You can double check if you're worried. You find the intersection of these other ones and note that this intersection is outside the bounds. So I definitely don't care about the next one. So use my graphing calculator. And I get the time that makes sense in this case is to 3 decimal places 1.428. And lastly, part C says for the particle described in part B, find the position vector in terms of t. Then find the velocity vector at time t equals 1.5. So the position vector, the position vector is just the vector x of t and y of t. And since x is equal to r cosine theta and y is equal to r sine theta, we already know what x is. We already found it up here. That's 4 minus 2 sine theta times cosine theta. Repeat with y, just now there'll be a sine theta on the outside. So I think the position vector is the vector 4 minus 2 sines t squared times cosine t squared, and then 4 minus 2 sines of t squared times sine of t squared is the position vector. What's the velocity vector? Velocity vector is equal to, well, the derivative of x of t and the derivative of y of t. You could figure out what the expression for this is and then plug in t. This is on the calculator part, so there's no real reason to do that since we have the calculator page, or on your graph calculator, you can find derivatives at numerical derivatives at a given point, and I highly recommend you use that. So what I mean by that is I'm gonna use my menu calculus numerical derivative at a point. X is my variable. I'm going to find it at 1.5. Here's the template that it's using here, and I'm going to find the first derivative, hit OK, and now I'm going to type in my functions. And I'm going to type in the x function first and get a value of x prime at 1.5. And x prime, x's, is this first thing, 4 minus 2 sines of x squared times cosine of x squared. I'll put in the multiply symbol. And we'll evaluate that at 1.5. And we get negative 8.0721. Negative 8.072 to 3 decimal places. And then same game but with a y, and I should just need to change that cosine to sine. So I'm going to come back here and edit this, take out cosine and put sine in its place. and get negative 1.6729, or to the third decimal place, to thousandths place, 3.